Hello, today we're going to look at aldehydes and ketones. We're going to compare and contrast them, list their uses, and look at reactions, how to form them. The reason that we're talking about aldehydes and ketones is that they both have a carbonyl group as their functional group. And the carbonyl group is a carbon that is double bonded to an oxygen. And both aldehydes and ketones have this carbonyl group. The difference is where the carbonyl group is located. In the aldehyde, the carbonyl group is in the end of the carbon chain. So it's on the terminal carbon, which means that in an aldehyde, the carbon attached to the double bond oxygen, it's at the end of the alkyl group, so there's one bond to another carbon, and the fourth bond is to the hydrogen. If we're to look at the ketones, the carbonyl group is within the carbon chain. So carbon that's attached to the double bond oxygen. This time, because the carbon is within a carbon chain, it means that there is an alkyl group on both sides. So the carbon has two bonds to other carbons and no bonds to a hydrogen. Looking at the uses of aldehydes, it's used in the formation of plastics, and these plastics can be used in making buttons or making appliance and automotive parts, such as this old-fashioned telephone. The use for ketones that we need to look at is specifically to do with acetone. And acetone, you know, it's a ketone because the ending -one is used as a solvent in nail varnish remover. How are aldehydes prepared? Well, they're made by oxidizing primary alcohols. And it is important that we don't just look at any alcohols, they have to be primary alcohols. Because in a primary alcohol, the functional group, the hydroxyl, is on the end of the carbon chain. And we need to use an oxidizing agent such as hot acidified potassium dichromate. Now I'll draw you out the example that I have written the formula for. So this is propanol, and we know it's propanol because there are 3 carbons in the longest continuous chain, and we can see that the OH hydroxyl group is on the terminal carbon. Now what happens is when it is oxidized, this carbon-hydrogen bond will break, and also the bond between the oxygen and the hydrogen will break, and instead we're going to form a new bond between the carbon and the oxygen. So 2 hydrogen atoms are released into the acidified solution, and instead we are forming now an aldehyde. So now we have propanol. And it is important to notice that none of the carbon-carbon bonds were affected, and the only carbon that had any changes happening was this terminal carbon. It's the only one where any bonds were broken and formed. The rest of the carbon chain stayed the same. Now ketones have their carbonyl group in a different place, so they can't be prepared from primary alcohols. They have to be prepared by secondary alcohols. And again, it's an oxidization reaction. So we're going to be using the same oxidizing agent, the hot acidified potassium dichromate. And in the example that I'm giving you, I'm using the same carbon chain. We're still going to be using a 3-carbon alcohol, but because we're forming a ketone, the hydroxyl group is going to be on the 2nd carbon and not the 1st. So here is propan-2-ol or 2-propanol, the hydroxyl group, is attached to the second carbon. And what we're going to be doing is we're going to be breaking the carbon-hydrogen bond on that carbon. We're going to be breaking the oxygen-hydrogen bond in the hydroxyl, and we're going to be forming another bond between the carbon and the oxygen. So our product has the same carbon base, which, just like we started with propan 2-ol, we are going to end up with propan 2, but this time -one because it is now a ketone. Now I'd like to do an ending summary. So I've shown that primary alcohols can be oxidized into aldehydes and secondary alcohols can be oxidized into ketones. But what about tertiary alcohols? Well, if you look at tertiary alcohols, you can see that on the carbon with the hydroxyl, there are no carbon-hydrogen bonds. They're only carbon-carbon bonds. And we don't break a carbon-carbon bond, so tertiary alcohols cannot oxidize further.